Welcome to 44th lecture, and we have been discussing the effect of third harmonic flux and third harmonic currents in particularly three-phase transformers. Star-star connection without neutral always causes problem, including single phase loading is not possible because secondary neutral becomes oscillating and so on. But if it is a delta connection, if exists either in primary or secondary, at least one is delta connected, then in the lines there will be there is no possibility of any third harmonic current to exist if it is that side is delta connected, because they are cophasal and so on. But nonetheless, there will be induced voltage then in the coils itself, and these coils are close to itself. Therefore, the magnitude of the third harmonic current, circulating third harmonic current, will be then their cophasal 3 E third, 3 times of that divided by the leakage impedance of, suppose the secondary side is delta. This third harmonic current will circulate like this. So, 3 times C third divided by the leakage impedance of this side, but if the at the fundamental frequency leakage impedance is x 1, it should be J 3 x 1. So, impedance also increases and there will be circulating current, little bit, and this may cause extra heating, no doubt, because of this circulating current there will be copper loss, extra copper loss and so on. But nonetheless, that major problem of getting at the output a voltage which will also have third harmonic component is avoided. That is what is important. So, it causes extra heating, slight extra heating will be caused. In any case, now the question is what is the I will tell only general guidelines. For example, generally HB side, so it looks like one of the side better be having delta connection. So, generally HB side is chosen as star connection. Why? Because the voltage per phase will be less. So, insulation level etcetera will be lesser, and LV side, since the coils will be delta connected, this will be low voltage, this is high voltage side. This voltage will be also less because of this one, and let this be delta connected, that is the guideline delta. But this is not all. In fact, there are situations, other reasons will override this, that is maybe the low voltage side is star, primary side is delta. For example, a distribution transformer, typical rating is 6.6 kV and 440 volt. What is done? Because this side, it is a distribution transformer, you must have the 3 phases as well as neutral. So, this must be of star connection, and this must be this can be selected as delta, because of the fact one of the windings I want to be delta, that is the idea. And from this I will be able to supply A phase with neutral to a group of consumers, from B phase and neutral to another group, and C phase to neutral to another group, 220 volt supply etcetera can be done, and everything is fine. So, depending upon the situations, general guideline is high voltage side better select star, low voltage side delta as perhaps one of the windings be delta connected is always preferable. And sometimes if the voltages are high, what people do, they use star high voltage on both the sides, okay, relatively high voltages. So, then select star star, but with star star there are problems we have seen. But what people will be doing, they will also put another coil which will be delta connected. That is, there will be two secondaries, because it is always preferable to have a delta, and you suppose you require star star, nothing doing, high voltage this side, high voltage this side, I will take advantage of lower insulation level, this that. So, it is like this, and you connect it and another additional windings. Therefore, for each phase then, if I draw the limb of say A phase, it will be like this, A1, A2, and then small A1, A2, and another A3, A4. Two separate secondaries are there for each primary, similarly for B phase and C phase. Now, in this case we have seen that, and these two terms may not be same. In case of zigzag connection, we saw this type of secondaries present, but those two secondaries were identical, same, having same number of turns. You recall that? So, here it is N1, maybe this is N2, this is N3. Now, what I am telling is, this is star connection A1, A2, B1, B2, like that, and perhaps this is the main secondary, this is main primary, which is star connected, maybe this is A1, this is A2, B2, C2, etc. And this is also star connected, this is say A1, this is B1, correct, B1, and this is say C1, correct way I have connected, and this is the neutral A2, B2, C2 I have connected, and this will go to the load. And this one I have connected in delta, this A3, A4, similarly you will have B3, B4, I think you are understanding what I am telling, and you will have C3, C4, like the other two limbs, and these I will connect in delta, got the point. So, you connect them in delta and three terminals will come out. Here this winding which is connected in delta is called tertiary winding. Which is primarily added so that third harmonic current, about that problem you need not worry about, circulating third harmonic current will flow. Not only that, you can get then two different level of voltages and supply to different loads also. Okay, suppose some people use primary star, secondary, main secondary star, and also here whatever voltage you get, you supply another 3 phase load. that is with 2 secondaries then, but sometimes no load is connected. It is merely it is present because you provide the flow of the third harmonic magnetizing current in this winding. So, depending upon the turns ratio, 2 levels of voltage you will be load may or may not be connected, load may or may not be supplied, may not be supplied. From tertiary winding. I think you have got the idea. So, high voltage, star, okay. Then delta, since I was telling you, it is always better you have a delta connection somewhere, and all these windings are wound on the same magnetic circuit. So, like A phase you have B phase, C phase like here. So, that you B 1 B 2, here also small B 1 B 2 and C 1 C 2, small C 1 C 2 and then C 3 C 4. So, you have 2 secondary coils and then need not be of same turns, depending upon your voltage requirement you can decide what should be your N 2, this is N 1, this is N 1. This is N 2, this is N 2 and this is N 3, is not, this is the thing. Okay. So, we now understand that okay, the things goes 3 phase transformer connection we have learned, that is if I ask you make a 3 phase transformer connection star delta, delta star without first really questioning where should I use it, that first I discussed confidently how can you do it, do polarity test, do that. And then we have very qualitatively of course discussed about the third harmonic importance of third harmonic magnetizing current to be present in the transformer in order to make the flux sinusoidal, hence the load voltage will be sinusoidal. I do not know whether I have a previous one is there, no. Acha, let me tell you one interesting thing. For example, zigzag connection also we have done apart from star delta and this one. Let me try today to do another zigzag connection just to telling you. See, suppose I want to make a delta zigzag connection. Okay. Why I am coming back to zigzag once again is because of the fact in star star zigzag connection, if you recall 2 phases of on the secondary side belonging to 2 different groups, they are connected in series. Okay. And the polarity, dot polarity of this one, we discussed about y z 1 for example. Let me tell that once again, so that you also have a practice and for example, suppose I want to do y z 1, what should I do? Primary, it will have 2 identical secondaries, this time it is identical not tertiary or secondary. This is N 2, this is N 2, okay. This is N 1 and this is A 1 A 2. Let me do first A 1 A 2 and A 3 A 4, is not, then B 1 B 2, this is small B 1 B 2, this is B 3 B 4 and finally, you have C phase C 1 C 2 and small C 1 C 2 C 3 C 4 and all these odd numbers are dots. Relative to its primary, this is one set, this is another set and this is another set. And suppose I connect these two in star, because primary is to be connected in star, then the I will connect these two supply AS, BS and CS. And your primary phasor diagram will be very simple like this. This is suppose AS, BS, because supply voltage is balanced CS, and AS mean A1 only, this is B1 and this is C1, and these are A2, B2, C2. This is the neutral of the transformer N. Now, on the secondary, you have got these voltages A1, A2 and A3, A4. I am not explaining because we know this, and this is 120 degree apart B1, B2 and B3, B4, and finally, you are also having parallel to C phase, and this is C1, C2 and C3, C4, is not. In this way it is there. Now, suppose I because zigzag connection is essentially star connection, we know this is group 1 and this is group 2. Okay. So, I want to get Y Z 1 means this is the primary voltage with respect to this secondary voltage will be lagging, a line voltage with respect to secondary neutral will be lagging by 30 degree, is not. These will be the phase voltages. This we have done, I will do very quickly. So, this is the thing. Now, while getting this voltage, I want to get A1 generally here. So, your output voltages will be this and this, and as you can see it is A1, A2, and this is parallel to C phase, and this I will take C3, C4, is not. Similarly, this fellow can be broken up into these two phasors, and this is B1, B2 and this is A3, A4, and this can be broken up into these two phasors, this one parallel to B3, B4 and this is parallel to C3, C4, C1, C2, is not. Then based on this I come here and connect accordingly. For example, A1, A2 is connected to C4. So, take a piece of wire, connect it, and which three are shorted, A3, B3, C3, short them, is not. I short them, and I connect. So, ones will be the output terminals A1, B1, C1, these will be my output terminals. Then B2 is connected to A4. So, B2 is connected to A4 and C2 is connected to B4. And your connection is over. Now, only one point why I have redrawn once again is that only one point I want to tell. So, it is effectively a star connection, there is a neutral point, solid neutral point A3, B3, C3, and there are 3 lines. Only thing is between the neutral, secondary neutral, that is N, to one of the lines, if you start your journey from neutral, you will come across 2 coils belonging to 2 different phases, that is A phase and B phase in this case, if you start N, from N traverse A3 A4, then traverse B2 B1 and get your supply B, this is supply A, load supply side, this is C. So, two coils are in series. Now, suppose in this connection neutral is not connected, therefore, and there is no delta connection. Therefore, I am sure the current no third harmonic current exists here, only 50 hertz component of current will flow, and in the core of the transformer third harmonic flux must exist, and that third harmonic flux is going to induce voltage both in the primary and the secondary coils, is not? And the polarity of those voltages are shown here. Now, so far as the third harmonic voltage is concerned, you see they are cophasal. If this is plus, this is minus E third, fundamental I am not showing, and then this is also third harmonic E third. In all the coils third harmonic voltage will be induced, and so plus to minus and then minus to plus, and you reach the neutral. So, what is the third harmonic voltage present across the phases? 0. Although in each coil third harmonic voltage exists, but in the phases no third harmonic voltage. So, it is a superior thing compared to simple star star. Better take a zigzag coil, which will at least ensure that there will be no third harmonic voltage in the phases, that is this voltage, it will be RMS value only in the phases neutral to any of the lines, and between the line of course, it will not be there. Therefore, it is a better proposition that way, is not. So, zigzag connection has another interesting connection that perhaps I will tell later, or in your course of power system you will learn very easily now after you have understood this, that it can be used as a grounding transformer, a better choice for a 3-phase transformer. Anyway, that I am deferring now. So, for example, this connection we have understood. Achha, another small connection, as I was telling with D, suppose I want to do a delta zigzag, which I have not told, but let me do it. Suppose the primary winding is no delta connected zigzag winding I have done. So, that is why I am doing, so that you become more confident B 1 B 2 and C 1 C 2, and delta connections and it has got two secondaries identical N to N 2 turns, mind you it is not tertiary one of them, and this is N to N 2 turns. What is the point of writing? These are all same turns. This is also N 2, this is also N 2, two secondaries corresponding to each phase. It is essential to make a successful connection to mark the terminals meticulously. I mean, you cannot do arbitrarily something B 3 B 4 and C 1 C 2, small c 1 C 2, small c 3 C 4. Now, suppose I have decided I will connect it like this, delta like this, and I will give supply AS here, supply BS there in the B phase, and supply C phase. That is how I will give supply. Now, this side is delta connected. So, what is the rule? Rule is pretty simple, supply voltage is balanced, better draw that, that is AS, BS, CS, which is balanced, I know, that is why I could make a equilateral triangle and show it, and AS is once again you write with different colors. Say AS means what? A1 C2, A1 C2, and BS means what? BS means B1 A2, B1 A2, and CS means what? C1 B2, C1 B2, is not same points. And on the secondaries now, you have these voltages available to you. What are the voltages? A1, A2, A1, A2. Similarly, parallel voltages of equal length A3, A4. Similarly, B1, B2, another voltage is available to play with, B3, B4, and C1, C2. So, C1, C2 and C3, C4. Now, I want to make some connection delta and secondary side zigzag. In this case, you will find dz 0 degree or dz 180 degree is possible. Okay? Or so, how it is possible? Because with respect to neutral, on the primary side, this is the artificial neutral. Secondary side voltage will be also in phase with this, parallel to this, A phase voltage of the secondary side, and zigzag connection means star connection. Two coils belonging to two different phases are to be connected in series. One should be taken from group 1, other should be taken from group 2, the same rule. So, and I would like to have the secondary voltage, because no phase displacement, perhaps it will be, I will take A1 A2, and is this voltage available? Yes, A1 A2. Then I have to connect another voltage from other group of this kind, which is available in C, and I will take it as C3 C4, is not? And the B phase voltage will be 120 degree apart, and B phase is horizontal actually, do not put it like this, it is horizontal B1, B2, and this is B3, B4, these are horizontal. Why? Because B1, B2 is this. So, this voltage is the secondary phase voltage, and it will be it can be obtained like this, A and B. So, it can be drawn like that. I mean this no. So, here I would like to have B1. So, I will sketch it B1 first, which will be horizontal here, B1, B2, and then A like this. And what is this voltage? A4, A3, A4, A3, and finally, so you can sketch it like this. This is A1, which is this is B1, and this is some C phase here. Similarly, this can be drawn like this here, and you can see this will become B3, this will be horizontal actually, B3, and B4, and this point is C1 C2. Is this okay? B1 B2 was like this. So, this is fine. A3 B3 C3 have to be shorted, you short them, and then A2 C4 you join, A2 C4 you join, and then B4 C2 you join, B4 C2 you join, and finally A2 C4 I have joined, A4 B2 you have to join, A4, and this is 2 A4 and B2 you join, these two will be output. Similarly, you will be able to calculate this one. Only one thing I will tell, in this case suppose I want to these terms are known N1, N1, N1. This is N2, N2. Now, same flux is linking this. Suppose you have applied a line to line voltage VLL here. Try to understand what I am doing. I know the turns ratio, I have applied VLL, which is known. I want to know what will be the phase voltage on the secondary side and what will be the line to line voltage in terms of this VLL. How should I proceed? What is the voltage per turn? VLL by N1, because it is delta connected, line to line voltage comes here by N1, and what will be the induced voltage? RMS value VLL voltage per turn into N2, and this RMS voltage will be same for all these coils, because they are having same turns. So, I know the length of each phasor here to be VLL by N1 into N2 across each secondary coil, is not? That is voltage here VLL by N1 into N2, VLL by N1 into N2. So, the lengths of these are known. Then what will be the phase voltage? Secondary phase voltage very simple, this is 30 degree, this is 30 degree, and I know this length. So, each length, that is VLL by N1 into N2, cos of 30 degree will give you half, twice of that, cosine 30 degree into twice of that, because projection of this is also same. So, this it will come out to be root 3 VLL N2 by N1, root 3 by 2, 2 cancels out. And what will be the line to line voltage available on the secondary side? Root 3 times this phase voltage, that is this one is the phase voltage. So, secondary line to line voltage will be root 3 times this root 3 VLL N2 by N1. So, what are the things? It comes out to be this. Similarly, try on your own that start zigzag connection. If the line to line voltage is known, what is going to be the phase voltage and the line to line voltage? So, we will continue our discussion on transformer next lecture. Thank you.